Hello viewers, today we will see into area of a triangle. A, B, C are the three vertices of a triangle. Triangle is a polygon with three sides, and AC, AB and BC are the edges of a triangle on a plane. So to find the area of the triangle, we can just drop a perpendicular, a median line, and the formula we already know is area is equal to half into base into height. So we'll just look into what are the other possible ways we can calculate the area based on the coordinates, as this is part of coordinate geometry. So the other way to find the area by Heron's formula, wherein area equal to square root of S here is a semi-perimeter, S into S minus A into S minus B into S minus C. Here A, B, C are the length or the sides of the triangle. If A, B, C is a triangle length, and the S is here the semi-perimeter. We already know the perimeter of the triangle is side 1 plus side 2 plus side 3. So semi-perimeter, it's half of it. And here we have seen the length is A plus B plus C. S1 plus S2 plus S3 are the C3 sides. Then A is the one length, B is the other side, and C is the other side. So the semi-perimeter is going to be A plus B plus C divided by 2. So this is the other way of finding the area of triangle. And when we know so if we have a triangle PQR on a plane with the coordinates known, then by dropping the perpendiculars to each of these vertices, we get to see three trapeziums formed over here: PQAB, PBCR, QACR. So by calculating the area of the quadrilaterals, all three, and subtracting the down below part, the trapezium, QRCA, we get to know the area of the triangle PQR. And also we should know for this the area of the quadrilateral, which is nothing but half into sum of the parallel sides into the distance between those two parallel sides of the trapezium. So the area of the trapezium is QABP is a trapezium, and Y2 and Y1 are the parallel sides. X1 minus X2 is the distance between A and B. First we will calculate the area of trapezium PQAB, which is nothing but half into sum of the parallel sides into distance between those parallel sides. So here area is going to be half into sum of parallel sides, that's going to be QA plus PB, and the distance between them is AB into AB. Now we see the coordinate points of the respective thing QA, PB and AB. We get to derive at the area of this trapezium. So QA is Y2, PB is Y1, so half into Y1 plus Y2, Y2 plus Y1, both are same in addition. And the distance between AB, that's going to be X1 minus x2. Similar way, we have to find the area of the other two trapezium. Area of trapezium PBCR, that's again going to be half into y1 plus y3 into distance between those sides. That's going to be x3 minus x1. Area of the trapezium QACR is going to be half into y2 plus y3 into the distance between those two sides. That's going to be x3 minus x2. So we got three areas of three different trapeziums. So now to sum up two trapezium and exclude QACR from that, we get to know the area of the triangle PQR. Area of a triangle PQR is equal to half into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Very easy to remember. It is always in consecutive order. So x1 then followed by y2, y3. Similar way if x2 then followed by y3, y1. So it's always consecutive. 3 followed by 1, 2. So you can just easily remember the formula also. Area of the triangle when we know the coordinates of the triangle. If the triangle's one of the vertices is an origin, that's 0, 0, then the area is going to be AD minus BC divided by 2. If the other two coordinates are A, B and C, D. And when the area of triangle is 0, that means all points are collinear, meaning they all lies on the same line. So with this all concepts of area of triangle, we can solve the next exercise 6C. First question, find the area of a triangle ABC whose vertices are given below, A, B and C. We already know the formula of area of the triangle. That's going to be half into let's first write the formula x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. It's in consecutive order, so it is easy to remember the formula for the area of triangle by substituting the given coordinates. X1 is 1, y2 is 3, minus of minus 4 becomes 7, so 1 into 7 is 7, plus x2 is minus 2, y3 minus y1, that's going to be minus 2 minus 6, so minus 6 into minus 2, that's 12, minus of minus becomes 12 in product, plus x3 is minus 3 and y1 is 2 minus 3, that's minus 1. So minus 3 into minus 1 is plus 3. Now by further simplifying this, 22 by 2, that's 11 square units. That's the area of triangle ABC. I'm just solving in each type, one question in each pattern. Next question 2, find the area of the quadrilateral ABCD. So it's a four-sided polygon and the vertices are given below. So just by bringing in a diagonal or drawing a line AC, you can slice this quadrilateral into two triangles and then calculate the area of the two triangles and sum them up. That gives us the area of this whole quadrilateral. So ABC is one triangle, ADC is other triangle. By calculating two different areas and summing them up, we get the area of the quadrilateral ABCD. So area of triangle ABC equal to half into 3, that's x1, into minus 5 minus 0, y2 minus y3, plus x2 is 9 into 0 minus of minus 1, that's plus 1, plus x3 is 14 into minus 1 minus of minus 5, that becomes plus 5. So by simplifying this, half into minus 15 plus 9 plus 56, that's half into 50, which is going to be 25 square units. Similar way, we have to calculate the area of the triangle ADC. By taking the respective coordinates. So that's going to be half into 3 into 0 minus 19 plus 14 into 19 plus 1 plus 9 into minus 1 plus 0. Further simplifying, it becomes half into minus 57 plus 280 minus 9, that's 214, which is 107 square units. By adding up these two areas, we get the area of the quadrilateral ABCD. So that's 25 plus 107, which is equal to 132 square units. Next, question 6. Find the area of the triangle formed by joining the midpoints of the sides. So ABC is a triangle. By joining the midpoints, you get a new triangle. Let's assume it as DEF. So we need to find the area of the inner triangle, that's in blue, which we can get the coordinates by calculating the midpoints. As it's clearly mentioned, the midpoints are those vertices of the inner triangle. So by taking the midpoint formula, we can calculate the vertex of D, that's 3, 4. Similar way, for the E, that's going to be 2, 3. And for F, it's going to be 3, 2. So now we got the coordinates of the triangle DEF. With that, we can calculate the area of the inner triangle. That's half into 3 minus 4 plus 3. which is going to be half into 2, that's 1 square unit. So area of the triangle DEF is 1 square unit. Question 7, we got 3 coordinates A, B and C, and AD is its median. Prove that the median divides both the triangles equally. The newly formed triangle ABD and ADC have the same area. So we need to calculate the two different areas of the two newly formed triangles, and if it's same, that proves this. Yes, it is equal. So let's first calculate the value of D coordinate. That's the midpoint of B and C. So by taking the points B and C, we calculate the coordinates of D using midpoint formula. So vertices of D, that's going to be 5 plus 3 by 2, that's 8 by 2, 4. 3 minus 1 divided by 2. So that's 2 by 2. So the vertices is 4, 1. So with this vertices of D, we can calculate area of two different triangles formed now. That is ABD and ADC. So area of the triangle ABD by considering the respective vertices, that's going to be half into 7 into 3 minus 1 plus 5 into 1 plus 3 plus 4 into minus 3 minus 3. That's going to be half into 10, which is going to be 5 square units. So if the area of the other triangle ADC is same, then that proves it's equally same. So area of triangle ADC by taking the respective coordinates, half into 7 into minus 1 plus 3 into 1 plus 3 minus of minus, or plus 3 plus 4 into minus 3 minus of minus 1, that's plus 1. That's going to be half into 10, which is again 5 square units. First area is 1, and by taking the second area as 2, from 1 and 2, we can say area of the triangle ABD is same as area of triangle ACD. Hence proved. Next question 8. Find the area of the triangle ABC and the midpoints are given which is passing through the lines of A. So we need to find the coordinates of B and C to find the area of ABC. Let's assume that it has x1, y1 as of now, and x2, y2, C coordinates. So equating to the midpoint, 2 is equal to 1 plus x1, as we don't know one of the coordinates, divided by 2. So that's going to be 3. x1 is 3. Similar way, minus 1 is equal to minus 4 plus y1 divided by 2. So y1 is going to be 2 minus 2 plus 4. So that's plus 2. So we got the coordinates of B. That's going to be 3 comma 2. So very similar way we can calculate the other coordinates C also with the midpoint formula, as we have the midpoints already. So 0 equal to 1 plus x2 by 2. So x2 is minus 1. Minus 1 equal to minus 4 plus y2 divided by 2. So y2 is going to be 2. We got the coordinates of C, that's minus 1 comma 2. So with all three coordinates A, B and C, now we can calculate the area of the triangle ABC. The area of triangle ABC equal to half into 1 into 2 minus 2 plus 3 into 2 plus 4 plus minus 1 into minus 4 minus 2. So that's going to be half into 0 plus 18 plus 6. So 24 by 2, that's 12 square units. So here with midpoint, we calculated the coordinates of the triangle ABC. In the previous question, with the coordinates, we calculated the midpoint and then found the area of the inner triangle. Next, question 9. A, B, C are the vertices of the parallelogram ABCD. If E is a midpoint on the line DC, find the area of the triangle ADE. So one of the coordinates here is missing, that's D. So by relating the midpoint formula, AOC is the same as BOD. By equating these two diagonals, we can get the vertices D. After calculating D, we can get the value of coordinates of E by taking midpoint formula between D and C. So by just equating the diagonals, DOB is same as AOC. With that, we can get the coordinates of D. So that's going to be let's assume the coordinate of D as X and Y as of now, and B we already know that's 8 comma 2. A and C also we know. So by equating the diagonals AOC and BOD, X plus 8 by 2 equal to 6 plus 9 by 2, which is 15 by 2. So 2 and 2 goes off, x equal to 15 minus a is 7. Similar way, equating the midpoints of the diagonals, y plus 2 divided by 2 equal to 1 plus 4, 5 by 2, 2 and 2 goes off, so y equal to 5 minus 2, that's 3. So we got the coordinates of D, that is 7, 3. Now we can calculate the coordinates of E, which is a midpoint to C and D. C is 9, 4. So coordinates of E can be calculated with the midpoint formula. (16 by 2), that's x coordinate, and y coordinate is 7 by 2. That's going to be 8, 7 by 2. Now we can calculate the area of triangle ADE because we have all three coordinates. We can calculate the triangle area. So area of triangle ADE equal to half into 6 into 3 minus 7 by 2 plus 7 into 7 by 2 minus 1 plus 8 into 1 minus 3. By taking the LCM, half into 6 into 6 minus 3 2s are 6 minus 7, that's minus 1 by 2 plus 7 into 7 minus 2, that's 5 by 2. So 35 by 2. 7 into 5 by 2 is 35 by 2 plus minus 16. Further simplifying, it becomes half into 3 by 2, that's going to be 3 by 4 square units. That's the area of the triangle ADE. Next, question 10. If the vertices are given, find the value of P and area is also mentioned. The LHS is given over here is 15 square units. So area of triangle ABC, where one of the coordinates is missing for vertex B. So that's going to be half into 1 into P minus 7 plus 4 into 7 plus 3 plus minus 9 into minus 3 minus P. Area of triangle is already given in the question, which is 15 square units. That's LHS. So 15 equal to half into P minus 7 plus 7 plus 3 is 10. So 4 into 10, 40 plus 27. 9 3s are 27 plus 9P. Minus into minus is plus 9P. So 2 goes off to LHS. That's 15 2s are 30 equal to 10P plus 60. So 10P equal to minus 30. So P equal to minus 3. So the y coordinate of vertex B is -3. And one more pattern you can see is when the area of the triangle is 0, that means the points are collinear. You can prove this pattern of questions also. I believe this is useful. If you find this useful, do share and subscribe. Thank you.